This is now, I think we're coming up on the 6-year anniversary Vegas programmers have been around, and we've been meeting once a month. And it's, again, mainly due to volunteers that come out of the woodwork and say, hey, I have something interesting I want to talk about. And today, Amin, who's going to be talking about beating big tech coding interviews, which a lot of our topics recently have been like towards juniors and stuff like that, looking to break into tech. And when I heard about this topic, I said, that's perfect, right? I can know how challenging it can be to navigate tech when you're kind of new to everything. And I think this talk will, even for us who've been in it forever, also we'll get something out of it, I feel like. So we're going to do a 30-minute presentation on that. And after that, I would like to invite, rock, paper, scissors, but we'll have Eli or Zeke come up and do a little code demonstration of their demos that they did earlier and show you what's under the hood on how those work. So without further ado, one quick thing at the end, I will raffle off one prize. It's like a IDE license for 1 year from JetBrains. So stick around for that. But yeah, let's get going. So give me that.
Thank you. Oh, interesting. All right, well, I can project. Thank you very much, Josh, for helping me organize and be here. It's a privilege to be here. I'm actually new to the Vegas area. I've only been here a week, so thanks, everyone. My name's Amin, and I am presenting Beating Big Tech Coding Interviews. So who am I and why am I qualified to stand in front of all of you and talk about this? So I'm a consultant. I specialize in DevOps and SRE. I've been in the industry for 15 years. I help companies transform I help companies transform their products and services using DevOps and SRE. So previous to then, I work at Meta, formerly known as Facebook, for 3 years, meaning I successfully underwent their interview process, and then afterwards I was trained on how to interview, particularly PE coding, which is pertinent to this talk, and PE systems. So what's the agenda? We're going to set the record straight on what a tech interview and a coding interview at a big tech company is like, what to expect, how to prepare for it, how you'll be judged and evaluated so you know what to do in order to get the best result, and then finally tips for the actual interview. So let's set the record straight. So you're probably thinking when you do an interview for a company like this, you're on a marker board, you're writing some nonsense on the marker board, it's very, very high pressure, and there are people that resemble aliens looking at you and judging your every move. It can be pretty stressful. And seriously though, yes, coding interviews can be indeed a little daunting. However, let's dispel some of the fantasy about it. No, these things aren't actually representative of an actual on-the-job experience. The way that I tend to look at it is when you're doing a coding interview, you're playing a game. And your ability to get that job is really measured by your ability to play this game. Now, there's a really interesting book called Cracking the Coding Interview, which I recommend you take a look at because it has some interesting questions. But also in the beginning, they had some interesting quotes that I wanted to highlight. Number one, interviewing is about answering questions better than other candidates, particularly they are not expecting perfection. It is going to be impossible to get perfection out of an extremely hard technical question. And then next, your interviewers haven't seen red, black trees since they were in school either. So I don't want you to have this idea that the people that are interviewing you are these massive computer science gods. They're not. They're just like you. They just have these interview questions they're delivering to you. But the number one quote that I took out of this was the following: it is what it is, so let's do the best we can with it. The coding interview process is very imperfect. I have friends of mine that are brilliant software engineers, but they shy away from the experience because it's so high pressure. So hopefully this talk will calm you down a little bit and give you the tools to be able to navigate one successfully. So let's talk about what is a coding interview actually about. What should you expect during the experience? So to begin, these things tend to be 45 minutes long. You're most likely going to have 2 questions. The first one's going to be the warm-up. That's going to be 10 to 15 minutes. And then the remaining time, roughly 30 minutes, is going to be the big meaty question. You're going to do this interview twice. The first one is going to be at the screen just to see if the company likes, what you got, and then they'll put you into the full interview loop. And then next, you'll do it during the actual interview loop. There is a possibility you'll do it again a third time, but I will talk about that later. So when you're interviewing, you're going to be either in person on a marker board or you're going to be sitting down on a video call, right? And during either of those scenarios, the interviewer is probably going to be looking down and writing a lot or typing a lot. They are, in fact, paying attention to you. I don't want you to have the feeling that they're not paying attention and to feel insulted. What they're doing is they're taking a lot of notes. They're evaluating your behavior, what you say, and that is actually going to be very pertinent information when they're evaluating your performance. So they're going to be heads down a good chunk of the time. So again, there's going to be two scenarios. One, you're going to be using something like CoderPad, which is basically a glorified, shared text editor. One thing, at least from my personal experience, don't expect to be able to test or run your code. It's just going to be a text editor. You're writing code in it. It's going to be very different from, let's say, LeetCode or Code Wars or anything like that. Now, before COVID, there were whiteboards. They were more prevalent. When I did the full interview loop at Meta, I had 2 interviews that were on a marker board. So it's going to be really important that when you're talking to the recruiter, when they're setting up the interview loop, ask, if I'm doing this on site, is it going to be on a marker board or am I going to be using something like CoderPad? Because with that information, it's going to help you prepare. And one little tip that I don't see a whole lot of websites talk about, there may be a scenario where you walk into the interview and instead of seeing one person, you see 2 people. Don't be scared. What that is you actually walked in on a shadow. What that means is that you have the interviewer and then you have someone shadowing them. So the scenario could be a more senior engineer, more skilled in doing the interviewing. They're just evaluating a more junior person's ability to interview. Or it could be the other way around. It could be a junior person learning how to interview and watching how a person well-versed in the process does it. All right, so that's, in general, the structure of how the interview is going to be. So let's go over the meat and potatoes of this, which is really how to prepare. There's no avoiding it. You're going to need to get comfortable with at least one programming language. I highly recommend not using Bin Bash. Who likes their shell scripting languages? I certainly do. All right. Unfortunately, do not bring these out in an interview because, yes, you can write these very fancy pipe one-liners, get the answer out, but you're actually walking all the way around the stuff that the interviewer is trying to check. So get a scripting language and be really, really comfortable with it. Also, another trap is to use a low-level language like C. I interviewed someone. They were obviously very good at C, but the problem was they had to conjure up all of their data structures just to get started with the actual problem. So do something a little higher order, or at least something where you can, instantiate data structures so you can get started quickly. Another thing, really, really important, you are not going to be able to use a search engine. So your ability to write code is all going to be in your head. So all of the method calls, all the classes, all the tricks that you usually use when implementing a solution, it's going to have to be in your gray matter. So as you practice, keep that in mind and avoid using Google as much as possible. So yeah, you have your knowledge of your languages. 1, maybe 2. Next, to get a little bit more in depth, you're going to need to know what data structures are part of your language and how to use them. So for the Python people, you have list, tuple, set, dictionary. Make sure you understand how they work, what their limitations are, and what the methods are so you can manipulate them. Now, here's something really interesting. How many people in this room are like DevOps folks? Am I the only one? Are we? Okay, thank you for admitting that. I know we're in the minority. So for you folks, when you're applying for SRE, or in the case when I was at Meta, production engineering, you kind of get it a little easier in the coding interview because they're going to say, okay, yeah, sure, can you, use the right data structures? Maybe we'll do a little bit of algorithm work, but it's not a major emphasis. They're going to be looking at things like, can you do file I/O? Can you do text manipulation? that sort of thing. They're not necessarily going to have you do full-on algorithm type problems. For the SWE folks, unfortunately, there's going to be more of that stuff, and it can't really be avoided, especially for companies like Google that are notorious for just slamming you with the algorithmic questions, even for SREs. All right, so you have your language, you understand how it works, you understand the data structures, you understand what you need to practice. So you need to practice. So just an aside, when I was preparing for my interview at Meta, I took a week off of work, and I practiced 3 to 4 hours a day. And I was doing several problems a day just to get into get the muscle memory of what it's like to actually participate in their interview. Is that kind of extreme? Yes, but for me, it was one of the most lucrative investments of time I've ever had. So let's talk about where you can get questions from. So yes, code wars, leak code, those things are really useful, but one thing that you can trip over, if you ever look at the answers from other people, you'll see one of those like really fancy one-liners that does everything. Avoid doing that. Make sure that your code is well structured and readable when you're implementing a solution. Don't fall into the bad habits that you'll see from the leak code and code wars folks. Cracking the Coding Interview, once again, is a good resource. It has a bunch of questions and also like the answers and clues riddled throughout the back, which is really, really useful. And it's also broken out across themes, so you can kind of assess your ability to do different stuff like math brain teasers or bitwise operations or any of that type of stuff. So if you know that there's going to be a whiteboard, definitely get one if you don't have one. Now, you don't have to spend a lot of money. You can go to Home Depot and spend like, I don't know, 15, 20 bucks on a melamine board. You're only going to use it for a short time, and you just put it on your coffee table or something, and you're doing it like that, right? And this is really, really important that you understand, like you're doing the whiteboard thing, because I'm left-handed, and I usually type 99.9% of the time, so my writing is trash. So I have to go and practice, making sure I'm writing legibly, that other people can read it, and I'm conserving space, and my lines aren't going this way. So that way, you actually have enough room to implement a solution and have a discussion and refine it with the interviewer. And then finally, if you're just doing regular plain text editor, or if you're using CoderPad, then just use a plain text editor. Again, you're not going to be able to run or test your code, so if you get questions in Code Wars or LeetCode, don't use their app. Copy and paste it into a text editor and make it as close to the actual experience of interviewing as possible. Two last things. Get familiar with Big O notation. That's a pretty big scope, so I'm not going to go into it too deeply as part of this talk. But what you need to understand is when you're doing the interviewer is going to poke at the time and space complexity of whatever solution you write. So it's going to be really important to understand how to speak about your solution in those terms. And then finally, like I mentioned earlier, you're going to want to replicate the interview conditions as much as possible. Number one, thinking out loud. So if you have a partner or a pet or just a rubber duck, use them as if they were the interviewer and speak out loud, because that is going to be one of the major things that you're judged on when you're doing the interview. And then finally, definitely do stopwatch. Because you only are going to have 15 to 30 minutes. Time is going to be very, very short. So it's going to be important to get used to the idea of being able to churn out a solution in 15 or 30 minutes, depending on the difficulty. So that's preparation. So before we talk about what it is, what you need to think about when you're actually doing the interview, let's talk about the 4 pieces of criteria that interviewers will look at when you're being evaluated. And this is very consistent with what I was doing when I was evaluating candidates at Meta, so this is pretty recent as of last year. Number 1 is communication. So like I mentioned earlier, you're going to be using your mouth a good portion of the interview. When you're posed the question, you're going to be asking clarifying questions. You need to understand very clearly the problem space and the range of motion that you have in solving a problem. You're also going to be describing the approach that you're going to take when writing out a solution, and then implementing it, and then actually walking through the flow of the code. Because again, you're not going to be able to execute it. You're not going to get that feedback from a program, so you're going to have to manually do that. And then finally, you'll need to handle feedback from the interviewer. They're going to be poking at you with all kinds of interesting questions. Having grace under pressure being polite, being communicative is going to be really important. So communication is actually really, really important, so I put it up there first. Next is problem solving. So understanding the problem is obvious. What's the big piece of the puzzle when you're doing the problem solving in a coding context? Are you using the right data structures and algorithms to tackle the issue? We were talking about big O notation, being able to have an understanding of what your time and space complexity is based on the different approaches you could take and being able to weigh which is the best one. And then optimizing over time if you have remaining time. Technical competency, this can't be avoided. Ultimately, you're going to have to write code on a marker board or encoder pad, and it needs to be mostly syntactically correct. You're not going to be able to get away with using pseudocode in a coding interview at these companies. And then finally, testing. So if you know there's like loop invariants, if you know that you might have unsanitized inputs or bad inputs or corrupted inputs, make sure that you're at least speaking out about it, if not writing coding defensively in your solution, because they will definitely be checking on that. And then, of course, they're going to be paying attention if you're correcting your own bugs too. So if you catch something, you mention it, you change it, they're going to take a note of it as part of judging your performance during the interview. So those are the 4 pieces of criteria. So another meaty part, we're going to talk about all the tips to think about when you're actually in the interview with the interviewer, given the question, what should you do? The biggest piece of advice that I can give you is to show as much signal as possible. Now, when am I talking about signal? Signal is kind of an internal term at these companies. What they mean is like all of those 4 criteria that I just mentioned, you need to be able to demonstrate all of those 4 as quickly as possible. Because again, you only have 45 minutes, right? And so when you're going through the second question, it is very, very, very likely you're going to run out of time. That is expected. That is okay. Think out loud. The interviewer will judge you on what you say, not just what you code. So there may be moments where if you run out of time, but you are reasoning through the problem, that might be a positive impact on your evaluation. I'm going to repeat this many, many times. Start with the brute force first. It's going to feel really dirty to write like an inefficient solution. But the point is to get code out there as quickly as possible to be able to demonstrate that, yes, I can write code, it is syntactically correct, it is well structured, I have understanding of the language, right? So always start with brute force. And you can mention, yes, this is O(n) squared, it's fine, but it works with small input sizes. And then finally, you should pick the right language for the job. Don't pick C. Don't pick things that have a lot of boilerplate and take a lot of time, because time is, there's not a lot of it. But a really interesting tip that I don't know if a lot of people know, you can pick different languages. So for the really smart folks that know a lot of languages and are really good at them, there might be certain problems that do really well with certain languages. So you can just say, I'm going to use this one for this, I'm going to use this one for that. You don't have to pick one language and stick with it for the entire interview. So now, the question is posed to you. What do you do? Well, first, make sure that in your brain, the question that is being communicated to you is actually correct. Like you have a clear understanding of what the question is. So repeat it back to the interviewer in your words and get a confirmation that, yes, this is in fact the problem. And on top of that, ask clarifying questions. Like I mentioned before, there are certain ranges of motion that you can take in terms of being able to solve a problem that you want to be able to explore with the interviewer. So I have a few examples. So for example, do you want me to print or return the result? That might affect how you implement your solution. You might be asking questions about the nature of the input files, especially for the SRE/PE folks in the room. It would be good to know that, so that way you're able to code defensively. And then once you have an understanding on what your plan of attack is, you understand, okay, I'm going to use these data structures, I'm going to use this algorithm, or at least I have this basic idea of how I'm going to manipulate the data given to me to produce the output that they're asking for. Describe it in words first. Do not write code yet. So once you have that stated to the interviewer and you're getting a nod or at least an okay, then you start writing your solution. And again, we are focusing on brute force. We're focusing on making sure that it is understandable. We are not doing anything fancy, right? A really good really good tip, many of you, if you're doing it for the first time, you're gonna blank. There's something that you need to remember, like how do I, split a string by a token? What is that method name for this language? You're gonna forget. It's okay. Just say, you know what? I need to split the string. I forgot what the method name is or how to call it. I'm just gonna make it up. And the interviewer is gonna be cool with that. They're not looking for you to have, total 100% esoteric knowledge of every, string parsing library under the sun. They just want you to know that, yes, you need to split up a string, right? And then once you have that solution in front of you, you're going to go and verbally step through the flow of that code with some input that you create, right? And this is actually really important because it's going to help you, catch any bugs you might have, written into the code. So this is a way for you to be able to manually test the solution that you wrote. And then finally, if appropriate, mention what the time and space complexity of the code is. If you have a gigantic list of numbers and you're looping it over twice, so you have like 2 for loops, like, okay, this is O(n)². Yes, it does the job, but it would be terrible for large inputs. I'll have to iterate on this next. But at least you're showing the interviewer that you understand that, right? Rather than you just putting it out and saying, hey, this is a great solution. So let's say you got this code out, working solution, rough draft, in front of the interviewer, especially if it's the second question, right? If you do that, you're actually doing way better than a lot of candidates that come in. I've interviewed a good number of folks, and you'd be very surprised how far, or rather how short many of them go. So if you get to this place, you're actually doing very, very, very well. Because the problem was already hard from the start. Okay, so from this point, you're now going to have basically a question and answer feedback iteration session with your interviewer. Now, I know from my experience, I had a set of questions that I used. I was very familiar with them. I understood the various approaches that could be taken. I understood what it would look like across multiple languages. I would even have those examples in front of me on my laptop when I'm doing the interview. So it's going to be really easy for me to catch, maybe some anti-patterns, maybe some inefficiencies. So in that moment, I would be bringing that stuff up. I would point out, okay, what is this code? What are you doing with these variables? Is this actually usable? What is this loop doing? And when you're posed with those questions, take a deep breath, think, and usually the interviewer is going to throw some bones. If you don't quite get what it is that they're talking about, they're going to give you some clues. They're going to point it out a little bit. And then, take a deep breath again, be polite, and, address whatever feedback that they have. And as part of that, it's like what we were doing back at the beginning. Ask clarifying questions. Make sure you have a clear understanding of what it is they're asking to refine your solution, and just iterate. Now, again, if you've made it to this point, there could be a follow-up question that ups the ante really, really high. Like something that just makes it really, really difficult for you to reason about. If you get in that situation, don't panic. It's actually a moment where you should feel good about yourself, because what they're doing is they're stalling for time. So the interviewer is actually obligated to use the full 45 minutes with you. They can't cut it short. So if you've made it to the end, usually they have a question that is so outrageous that it's going to take up most of the time. And what will end up happening most likely is that you're going to reason about the problem verbally and not really quite get to code yet. But if you get to this point, you're actually doing really good, right? Because you've exhausted the question. So let's say you've done the interview. You get off the call, or you go home, you have a drink, you relax. Now you're wondering, how did I do? When will I find this out? What's the process afterwards? So at least for Meta, and I would imagine anywhere else, the interviewer is required to submit feedback in 24 hours. At Meta, there was like a tool, an interview tool that you had to use, and I had to fill out a report on every candidate and every interview, and I was filling in boxes for all of those 4 criteria I was talking about. So I'm like, oh yeah, I saw signal in this. They were very verbal. They were able to describe this. They were using this algorithm. They were using this data structure. It all made sense, right? But I have to do that within 24 hours because, eyewitness reports and in crime and things like that, like memories fade very quickly. Short-term memory fades very quickly. So for that reason, it is very important that I report on the interview quickly to give you a fair shake. So I mentioned in the beginning of the talk, it is possible you may have to interview again. I'll explain why that is. So usually what happens is the interviewer will state the level of confidence you have in the assessment for hire or no hire. So if I say, you know what, I mean, yeah, they did this, but I didn't get a lot of signal on these particular things, I'm not 100% certain in a hire or a no hire, they may decide, like let's say the other interviews you did were really good. They may say, you know what, we just need to re-interview you. So they'll just reschedule. If that happens, then that is a reminder that, yeah, do what you can to provide as much signal to the interviewer as possible. Maybe you just had a bad day. Maybe the problems that you were given were the ones that you didn't practice for. That type of stuff happens. And then just like a friendly reminder, don't share the interview questions on the internet. That's just no me gusta. So in summary, you now know what the interview is like. The interviewer is human. They are not, super computer science people. You know how to prepare for them. You know how you're going to be judged and evaluated. And then finally, how to participate in them so that way you're able to show your stuff and have the best chance of getting hired and getting a lucrative role. So here, I will pause for questions and feedback. And thank you so much for your time. Any questions, folks?
Can you give us an example of like a couple of the questions like that you could? I mean, obviously there's a why, but I'm just curious. What was your favorite interview question? And perhaps it's a little too technical, but
I will. Okay, sure. I will describe a question that is made up, but is very related to a question I got because I don't want to reveal a question that people have used. So how many of you know about the tool head in Linux? So like it's a command line tool, you run it against a file, it's going to print the top 10 lines of the file, right? So an example question for, the PE people, the systems people, implement head, right? And then, so I'm thinking, okay, well, obviously I'm going to need to open the file. Oh, is the file present? That's something I should probably catch. So I need to go and, well, what does it mean for a line? A line is a block of text, and it's going to be delimited by new lines, right? So I'm going to have to go and read the stream of data until I read, up to the 10th new line. And then I know that I have my 10 lines. How do you define a new line? Right. Then you're like, oh, well, that's supposed to be \n. Or maybe there's a different encoding for the text file. Like, how do you do that? That's a very good question. So,
Windows files.
Exactly. Am I running like is the data like regular Linux ASCII, or is it some Windows thing? Do I have to run to from DOS to make it work properly? That's a very, very good piece of feedback. Right, and I would say, okay, I'm gonna read it until I find my 10 new lines, and then I'm going to print the content. Right, and they'll say, yep, that sounds reasonable. You implement that, right, and then they may ask, okay, well, what if I wanted to specify, -n how many lines? How would you change your solution? Or what if the data file, each line of the data file is very, very, very large? Like, would that change your approach at all? So that's like the type of question that you could get, again, for PE and systems. I think for like regular software engineers, you might get something a bit more abstract. And hopefully you're not getting questions that are like, yeah, here's a red-black tree, and how do you do this thing traversing a data structure or something like that. But that is a decent example of what a question would look like and what the stages would be. That's a great question. Any others?
I just wanted to sort of re-emphasize some of the points you made with my own experience interviewing at companies that aren't sort of the big, really cookie-cutter style. I've interviewed at more like medium and small tech companies, and 95% definitely the same lessons. But I wanted to add or sort of re-emphasize: one, you will run out of time. Usually they have like a series of questions and escalations, and what you're looking for as an interviewer is not necessarily the person who gets the farthest, although that is obviously like a good sign of competence, but like you sort of got at, it's not necessarily the person who like remembers each of the names like a human dictionary,
right,
or like knows what the function is, but the person who, where like the process of working with them and getting to an answer is as effective as possible. So like you as an interviewee can be better at that process by like being stronger, knowing the names, getting the right answer quicker like off the bat, but also being more interactive, responding better to feedback. So that should also inform, like if you know you get thrown off more easily by someone asking you a question, get better at asking yourself those questions. Get better at like noticing your own bugs. If you, on the flip side, know that you tend not to be that cautious, get better at responding to feedback. Get better at being like, oh, good point, instead of like, oh, fuck. Yeah, the best single line I've ever heard from someone who was like decades my senior, there was at a company called Jane Street, that's a finance company. They said, I would much rather hire someone that I can like happily work with when you're accidentally called into the office at 4 a.m. than someone who's gonna like get it done 20% faster. It's like, it's someone you want to be in the trenches with. So keep that in mind, just like, I do think you basically said that, but it's not about being like the computer is the computer, it's about being like one of the best humans who the other person wants to work with around the computer.
Thanks for bringing that point home. Software engineering and writing code is a social exercise. So like companies are looking for people that are able to play nice and collaborate with others when implementing solutions to planetary scale problems in the case of these big companies.
Time for one more question. Anybody else?
Not as much of a question as a comment. So speaking to what you guys are talking about in terms of like, there's a lot of big companies that will essentially leak code you and ask you like a very specific data structure and algorithms problem. There's also a lot of companies that focus on the process of working with people. And on GitHub, there's a very, very popular repo by username Potato with an E. And it's like a database of companies that have more of that human like problem and answer based hiring process rather than just the plain DSA stuff. So
Yeah, that's awesome. That's good to know, because it might be better for you to work for those types of companies where you're able to have that type of interaction and that type of experience, where larger ones might be a bit more impersonal. Right?
Help you practice what you're getting into as well.
Right. Yeah.
Cool. All right. Thanks, Amin. Appreciate it.
It's a pleasure. Thank you.
And maybe not next month, but at some point, I'd like to invite Amin to come back. I'd like to do like a mock interview. So we'll grab a volunteer, and then kind of Amin will put them essentially through the same process as. It's funny because I've gone through my fair share, not only on the interviewee side, but on the interviewer side. And one of the funniest interviews I ever had, this guy knocked it out of the park, had all the right answers. At the end of the interview, we were goofing off, and at the end, he's joking, and we're like, just make sure, or like, how are you working with people and stuff like that? And he says, I'm a walking HR violation as a joke. But we didn't hire him because of that one, even though he was joking, that's probably not wise to say going into an interview. So, but yeah, exact signal. Yeah. So, Eli, do you want to go first? So, yeah. Okay, cool. And then, so we have enough time here.
Oh, we should share the slides in your group.
Yes. In fact, I think I'll double check, but go to meetup.com if you do want to check out the slides. I'll make sure I get that link posted in there in the comments. Yeah. Cool. If it's cool, like 12 minutes or something.
Sure.
Yeah, we're just want to make sure we don't go over. So Eli, if you were here just previous meetup, he was showing MagicHat. Very cool idea. I'm already asking him for feature updates. But now we're going to dive into the code. So maybe take it away. Talk us through the stack.
Yeah.
What you chose.
It's quite blurry, so we'll probably talk about it more.
You might need to zoom in a bit. Maybe just key parts, but
Yeah.
Does the projector not get more visible? Like the
If you get up here, I can read it. The problem is, I think it's just a text size.
Yeah, if we read every line of code, though, we'd be here for 12 years. So we probably won't do that. But
You could probably pinch and squeeze and zoom in on parts that
Yeah.
maybe are interesting.
It does seem a little out of focus, though. I mean, in addition to the text size.
Can you live share the code?
I don't see a way to.
that's better.
What libraries are in there? Sorry.
All of them. No. Yeah, this is Angular. This is all.
Package JSON, right? That'll show you what all.
Oh yeah, you could if you want to look at that. There you go. There's the production dependencies. Yeah, I think they alphabetical. Yeah, it's alphabetical too. So that's kind of nice, huh? Though that comes with Angular already.
Estate management, like NGXS or
I'm just using RxJS. Angular comes with services that will do global state management for me, so I use that a lot. So yeah, the tech stack, we don't have enough time to go through all the code, but we go through some high-level stuff. MagicHat, if you weren't here before, it's just a application to help you make a decision. You get this hat. This is a virtual hat, obviously. You put ideas in that hat, and you say, hey, pick an idea for me. Cool thing about this one is that you can also send the URL for that hat to a friend, and they can also, in near real time, fill in that hat too. So you can see the ideas just stack into it. If you want to see a demo of that, well, you can just go to the production site, magichat.dev, easy peasy. So check it out. Let me know what you think. There's a contact form on there. But as I don't have a lot of time, we can't go through too much of the code, but we can talk about kind of high-level stuff. Front end's Angular, back end is FireBase. I'm using pretty much everything you can with FireBase. I'm not using storage because I don't need images and files, but I am using the Firestore. I'm using functions. I'm using authentication. For all those things. Right now, there's not like an actual, like I'll log in with my account right now. I'm just using it for anonymous user login and then using that data to keep track of what's going on. What's going on code-wise? Well, let's talk about just a high-level idea of it. When someone goes into the site, creates a hat, that goes to the back end. You get a nice, beautiful little spinner. With a wand and circular stuff, try to keep you entertained while we're waiting for network calls to come forward and backwards. And then the hat gets created, that goes to the database. FireBase made it really easy, especially with FireBase, not store. What is it called? FireBase. Firestore? Yeah, Firestore, thank you. Yeah, Firestore to create live signals. Like, so if someone sends something to a database, it knows that, hey, who's ever subscribing client side, it can update now. And it's really nice that you can kind of choose and pick what's coming in. So if let's say we have a hat, we have 5 ideas in it, and you've already loaded in client side. You see those 5 ideas. If someone puts a new idea in, it's not sending all 5 and the 6th one. It's just going to send in the 6th one now. So it keeps it nice and tight and clean, and you don't have to worry about having so many more network calls than if you were creating yourself and thinking about it that way, right? Oh, this is cool. I love it when it goes away.
Possible to show some of the function code, like for consuming one of the items for a hat?
Like choosing a function, or
If I submit a new thing for the hat,
sure.
maybe what does that function look like?
Yeah, with the limited time, I wasn't sure what to really show. I was just going to ask people what they want to see. So if we go to components, we should have a create somewhere in here.
You're on it. Great.
Yeah, that was easy. Why am I looking up there, by the way? All right. All right, so we got lots of variables indicating form submission. We're creating the hat. So this is just the beginning, that first form where you get the title of the hat. Like what ideas we're throwing in the hat in that first idea. That is what's happening right here. We're going to grab the form, oh, geez. There we go. We're just grabbing the form control. This is instantiating it. So this is what's going to show up on the screen. Angular kind of has like their own forms module. And this is just instantiated. It's just saying, hey, make these valid and don't fill in the data with anything. Let the user fill in the data. And then on the HTML side, you can say put your idea here as a placeholder, put your first idea here. And then when we're submitting, not that one. We're starting to see the tooltip, toolhat, code. On submit, we're getting the hat tooltip. I don't know why I'm getting my hat tooltip. Those are just kind of like, those are just references to if it's empty or something. Like, hey, go back and fill it in. That's what the hat tips are. It's just checking those things. If it's blank, it doesn't think about it. But we'll go to the create hat function. There we go. We just make sure the form is valid. We start doing our loading spinner because we don't want them sitting there and having a dead app. My wand spinner, the spinner that you see with the wand and sparkly, that's a global, what's the word? It's a global spinner. I can call it anywhere in the app and it will start spinning it. So I don't have to put it in every single component. I can just call it once and you send off a signal saying, hey, spin that guy. So I don't have to reuse code a bunch of times. If the hat, and then we go ahead and we try to create the hat by sending in the hat data, which is right up here. We create a new hat, give the hat a name, the first idea. This is going to be an array inside a string array called ideas. And we're going to go send that off. I have a hat service that handles all my API stuff, so I can use that at any point. I can say, oh, I need to send something to the hat. I need to grab data. So you're not going to really see the underlining FireBase code in this one because I obfuscated it a bit to make it easier on myself. And once we send off that data, it returns the hat. I navigate to the newer URL where you'll have the opportunity to add more ideas. Of course, I'm using try catches. In this case, it's the then catch because it's TypeScript and JavaScript. They both use the same thing. If I do, so in this case, if let's say the hat has, I have lots of commented code. We could definitely read through it, but that'd take forever. That you get user timeout. That's that whole if a person tries to create a hat, they decided, hey, I need to create a new hat. I have that 1 minute timer, that block. That's what I'm getting sent back right now is just saying I'm going to get an error, which is going to go in the catch. I'm going to catch it, and then depending on what's going to happen, I'm going to get the next value, and I'll create all the variables and calculations to make that countdown timer, saying, hey, we got 44 seconds, 43 seconds, all the way down to 0 to create a new hat. So not much to that. Pretty easy. Obviously, I obfuscated that the FireBase code, which you might have been more interested in, but that's how you'd create a hat. Is there any other functionality anyone would be interested in? I think I got a minute.
Any styling libraries?
Oh yeah, well I'm using Bootstrap. That was inside the you saw in the JSON package. But yeah, I'm using Bootstrap. I might be doing a little bit of my own CSS, just not for that one. But Bootstrap's usually there so you can avoid having any CSS.
How many different components do you have? And I might have a series of them.
Not too many. A dozen or so.
Do you use a framework in terms of a model like the MVC type architecture that you use?
It's ARM. Yeah, this is MVC model view controller. Any of the anything you pop up, and you also get a spec, which is unit tests. But you're going to get your code, your CSS, HTML, so you get that kind of model view controller feel to it,
The reason I ask is because I'm still trying to figure out what's how to better develop an app, and then a lot of people try and sway towards the micro front ends and understanding the module federation. And I'm not sure what's best, but I'd like to know what was your thought process in saying hey, this time I'm gonna build this.
So pretty much for any application I make, I just create a simple dummy front end to start with. I like to start with the front end. How is it going to look? Where's my buttons going to be? Now I know there is a button. But now I know I'm going to need functionality for that button. I'm going to need functionality for the text I see. So I'll make a full UI and make some dummy backend calls, it's just things I'll store data, like an array or something if I'm going to use it. And I'll create a functional app, just the front end, client side only, no network calls, no extra complexity. And then from there, I can go to starting the back end, doing more of the complex stuff. I also teach a class at CSN when I tell students to, so at the last half of their class is building their own application. I do mobile app development there. And I always start them out with a wireframe. They got to draw it out. And then with that wireframe, they got to create their network calls. What kind of data are they going to store? All this extra high-level thinking. So once they actually do get to coding, they don't have to think about it anymore, right? They know every single thing that they need to get done. They have this checklist now, and they've already thought about like what you would run into when you would just go straight into coding. When you don't think about it, you're like, oh man, I didn't think about. I'm probably going to need to store this data in. I'm actually probably going to store a file with this too now, and they didn't think about that because they just jumped right into it. So now, if you wireframe, you draw it up, you think about what's going to happen, maybe little pseudocode mock-ups of what the code's going to do. Then, right when you go into it, you can have an idea of how to efficiently execute that plan. You're just doing check boxes. Like, okay, I've already made the whole high-level overview. Now I can do a Trello board or something and just start moving things to processing and done and call it a day.
So how would you determine in a sense where, since you're using FireBase, you can put a lot of your, like, I guess, I don't know, heavier functions inside they have like the functions, right? FireBase functions?
Yes.
Instead of like, for instance, like a contact form that could just be done through like a state manager or something like that.
Yeah.
How do you determine what to use in a function? Because
Okay.
the function's going to cost money from Google.
For sure.
Versus trying to, just do it without using a function.
There's so many factors. One would be cost, right? Because if you're like, it's like, this is a budget project. I don't want to be spending too much money. But if money is not as big as a deal, you're willing to spend a few bucks a month, right? You want to do data-heavy tasks, definitely on the function side, right? And so you don't want JavaScript and Chrome to be churning out that kind of data. You're just going to be sitting there all day. So use Google's processors. They're a lot better than whatever's going to be on most people's computers anyways. And also things that you don't want the user to have access to. In the case of MagicHat, I don't want someone to be able to kind of hack and say, oh, well, I'm going to just change the JavaScript code and make option 3 the choice and mess with everybody, right? So I send that off to a function that can only access the chosen data field in the database. If you try to do it to your side, you're going to get permissions denied. Only the function on my server side can actually choose which hat and modify that data field. So it's security and higher processing. But if you're trying to save a few bucks, maybe and the client's using it for free anyways, maybe they're willing to use their processor for things you can do it on the JavaScript side. Sir.
You teach, right?
Yes, sir.
Did that help your coding get better?
Oh, yeah, definitely. I'm always constantly helping people debug their code. And sometimes you get a head scratcher. And yeah, I wouldn't, I'm kind of stumbling on words, but definitely, right? There's nothing, everything's the basics. And I teach a basic class, and it's good to refresh those things and see people's code and help them make it better. And I know that I can make my code better by didactically helping other people. Yeah. CSN.
For those of us who are relatively new to Vegas, what is that?
That's like, it used to be the Community College of Southern Nevada. Now it's called the College of Southern Nevada, but it's still the Community College. Just because now we offer a couple extra bachelor's classes, they got rid of the community portion. But there's campuses all over the place. I'm primarily at the Charleston campus, but there's one in Henderson, there's one in North Las Vegas. That used to be called Cheyenne, but now I think it's called North Las Vegas. But yeah, I teach Android in the fall, and I teach iOS in the spring.
When you say Android and iOS, do you mean like Swift and
Kotlin. Yeah.
I got one last question.
Yes, sir.
Percentage-wise, back end to front end, what do you think you spent on the project? Like 60% front end, 40% back end?
Definitely more back end on this one. Like I said, in my previous talk, this was a learning project to learn FireBase. So the front end was basically already created from the first iteration. From that first one, I would say mostly front end on that one because I was using bare bones talking to the backend. Like, it's not secure. There was no better thinking. There was no extra functionality to like secure what's going on or make sure it's the most efficient, right? This one was all about, hey, how do I use FireBase? How do I use their security rules? How do I store data efficiently? How do I get that data efficiently? So yeah, in this case, I would say this was definitely more like 60% backend, and then the front end was just taking my vanilla JavaScript, my vanilla HTML and Bootstrap, and just switching it into an Angular app, which was a little iffy. I'm noticing that Angular a lot of times has quirks to it that I don't think other frameworks have. Cool. Thank you.
Thank you, Eli. All right, our last speaker today is Zeke. Let me just steal the microphone from you.
Oh, of course. I keep on forgetting about that.
All good. Zeke shared his podcatcher. Did you name it? Is that the name, podcatcher, or?
We call it hubbub. So
Hubbub? Oh yeah, right. Okay, that's what I saw. Hubbub. Although I like podcatcher too, but hubbub I can live with. Yeah. Pretty cool. Some obviously there's some things that you kind of feel like there were things I wasn't expecting in it, like the transcribing stuff. So I'm interested to see, how you thought of tackling these things. Maybe like talking a bit about like solutions you saw that maybe you didn't go with because of maybe some reasons and stuff like that. Cool.
thank you. Ooh, it's a different one. Hello. All right. Start a timer so I know what's going on. All right, I'm gonna keep this sort of relatively high level because basically a lot of my backend is sort of me stitching together AWS blobs of code and stuff rather than a big monolithic anything. So I'm gonna sort of talk over the different services I use a little bit about what I learned about them, and then sort of try and leave as much time as possible for people to poke stuff and kind of choose your own adventure. So first of all, deployments. It's a React web app in the front end, so it's just in a Git repo. AWS Amplify is a thing that deploys Git repos to an AWS URL. It took probably 5 minutes to set up. We basically just log into GitHub and say like, this repo, this branch, please deploy it. It like auto-generates a build configuration file and stuff. So it basically just set and forget, and yeah, it's like pennies per deployment, and just charges for the actual time it takes to build.
That's the front end part that it's deploying?
Yep.
Yeah.
Yep. So yeah, I'm sitting on my computer with my Visual Studio, React repo, save everything, git push, and then I get an email notification that's like, we've started a build, and 2-3 minutes later it's like, we finished a build, and then it's available at that URL. And it's always a consistent URL too, so it's not like every time you deploy you have to like re-update it. So if you're just sort of, it's an ugly URL, but you can sort of bookmark it and always go there for your own little project. Audio, I mentioned this earlier. I don't know if the person who asked is still here, but turns out HTML5 has a built-in audio component, super easy to use. Yeah, highly recommend just like Googling for, is there something that already does this before you go invent your own? Yeah, it lets you basically hide controls and has like a set of functions you can call if you just want to make your own buttons for like play, pause, change the playback speed. The login and OAuth flow is, you can go to Google, can't remember what it's called, like Google Cloud Developer Console, I think, and create your developer account and like create your little app identity for free. And then if you've got it configured as like a beta app, it'll, I think, let you add up to like 100 emails to kind of your whitelist. But it's pretty easy to use. Again, this took a little more trial and error because like OAuth and login is always a bit of a, anything related to like login and privacy and security, your error messages are always terrible because nobody wants to divulge anything. But what I did really like about this is like, there are a lot of dialogues, like I don't have to, make JSON blobs for all this crap, or like, which sometimes you do. And once it's working, it's relatively easy to copy. You're like, all right, I had it working over here, and you just sort of like copy paste most of the same stuff and tweak it, and it mostly still works, which is less true for code. So yeah, highly recommend like playing with this once, getting some kind of login flow working, and just being like, all right, I have it if I need it.
Question?
So the reason it's on Google Cloud is because I wanted to log in with Google. Yeah. So I'm not actually using any of their like compute resources, databases, or whatever. AWS does have identity management. Amazon Cognito, I think it's called. I couldn't get it to work, but I was able to get the OAuth like to give me a token, so I stopped asking questions and stepped back from trying to use another AWS service. In principle, I really appreciate that I'm not storing any data about any users. That's obviously not feasible forever. I want to continue to be intentional about like what you need to store in your database versus the user can store for themselves, but at least like a list of who your users are and some like general stuff about that is something you can't get away from, at the very least, for like throttling and stuff like that. In terms of user data storage, as I mentioned in the original demo, I'm storing my config file in the user's Google Drive, which is why I appreciate logging in with Google. It has a separate permission for like, give this app access to only the files you have like given it, which for my purposes means like it can create files but can't actually see anything else in your drive. It was lovely. I didn't have to spin up a database. I don't ever have to worry about like accidentally finding a different user's information when I query for this thing because I wrote a bug. You like can't find the wrong file because you're authed to G Suite with this user and this app. And text is really small. Like I feel like we undervalue this nowadays, but like text is fucking tiny. You can store tons and tons and tons before the user cares. It's like you can store, I mean, yeah, my entire config file is smaller than like an image. And I'm storing a ton of data. You can compress it by a factor of 10 if you just run it through some text compression. So highly recommend. Yeah, it's not the kind of thing where you're like, secretly profiting off the user and not developing your own infrastructure. Like it's not a volume that they care about. Oh yeah, and on the right here, I just want to say, yes, this is not something you can apply to everything, but I feel like this idea of like, we don't need to own your data, you can keep owning your data is undervalued, and so it's good to keep in mind, and yeah, super easy for bootstrapping. AWS API Gateway is basically just like a request router. You set up like, all right, you've got a root URL, and you're like, all right, I want to have these sub URLs and these methods, and I want you to like link it over to this other AWS thing that does actual stuff. And it has basic API, bread and butter, par for the course stuff like rate limiting, has some support for authorizers and like parameter validation and stuff. So it's nice, just like easy layer above your real backend. The part of my podcatcher that actually fetches the data is, so in principle, podcasts are just like RSS feeds. It's like some file that typically the podcast host has like hosted on their server somewhere, or like gone to a site like Feedburner or RSS.com and like hosted it there. But so the app is basically like reaching out into random parts of the internet to download like the latest RSS feed data. Browsers don't like this. They've implemented something called cross-origin resource sharing. If you ever see a CORS error, this is what it is. Basically, it's just an extra layer of security where, like, if the resource you fetch says, doesn't explicitly say, hey, I was designed to be fetched by web browsers in this particular way, in this particular format, the browser won't let you because it thinks you might be getting hacked. So for that reason, the part of the code that fetches the feed details is running in AWS so that my client code can reach out to like an AWS URL it knows, and that URL is like, yes, I'm meant to be used by browsers. And in the back end, it's a blob of Python that takes the URL you asked for, reaches out, grabs all the RSS data from the internet, parses it, prunes it a bit, cleans it up, and then caches it in AWS S3. It's the closest I get to a database. I looked into things that Amazon actually calls caches, like Elasticache and stuff. They're expensive, mainly because they're like actual caches. They're like servers running and trying to store your stuff in memory so it can like return your answers really quickly. At a minimum, it was going to cost more than like everything else combined. So I stored my stuff in S3 because cache is a relative term, and if the thing I'm comparing to is reaching out and spending multiple seconds fetching feed data and parsing it, then spending like a couple milliseconds longer than a real cache to go look something up in Amazon S3 and pull it back is fine. Still saves me a ton of compute cycles. And in particular, it means that like the Python code running in Lambda is really quick. It'll like look things up in S3 and then be like, it's already there, I'm gonna return that. And that makes it cheaper.
Client does a little extra post-processing just for client-related stuff, basically, to group things and stuff like that. The functionality of searching for podcasts. I mentioned this a bit in the original demo, but it's I don't have the benefit of being a known name like Google or Apple or Spotify, so people haven't come to me and been like, please host my podcast. I need listeners. So I instead have to do all the searching for them. So it sort of included a blob of the backend code just so you can get a sense for like how spaghetti and awful and like heuristic-y it is. That's kind of the crux of feed searching. Like I'm basically doing, at the moment, I'm searching like podcast.google.com/search/ whatever you typed, and like scraping things from that page and looking for anything that looks roughly like a URL, and like filtering a bunch of stuff out, and then anything that's left, I like actually try and read the data from that URL and see if it's a podcast. But it's literally like, this was a significant chunk of work because you have to layer a lot of like heuristic cleverness that might not work to be able to take like 10,000 links down to like 5 links to actually check. Fortunately, a lot of stuff is like really obviously like images, and images are not podcasts. All right, deploying AI transcription jobs. So if you were here in the demo, there was a button I could click beside my queued podcast that would kick off a job in AWS and create a transcription after a few minutes. And you could load up this transcription when you're playing the audio, and sort of it's reading along with you, and you can skip and skim and stuff. I'm using OpenAI Whisper. It's incredibly easy to use. It has like a 1-line binary if you don't even want to use Python. And it's on their GitHub page, highly recommend. Their smallest model takes about a third of real time to run. So like if the audio file you're running on is 10 minutes, it takes like 3 or 4. It's been good enough for me. I'm worried about spending a lot more compute resources on that because it's like frighteningly good and then hilariously bad at places, but the number of times it's hilariously bad are like few enough that it doesn't matter. If I were doing something where like, it works for me because I'm playing the audio alongside the text and you're sort of getting the dual purpose or the benefit of dual media. If I were trying to really double down on like, consume this podcast only in text, I might care a little more about the model accuracy. Anyway, all that said, the way it works is, so I have the client kicks off an API request. So the first thing it hits is Amazon API Gateway, I mentioned before, which then like immediately bounces me over to AWS step function, which is basically like a state machine coordinator for other AWS services. You can basically drag and drop it graphically. It's really nice. And that pretty quickly just like kicks out to AWS Batch, which is a way of running sort of dynamically spinning up and spinning down infrastructure for like confined batch jobs. It's a little different from AWS Lambda, which is meant to be like things that maybe run for a couple of seconds or like maybe a few minutes if you really want to. AWS Batch is meant for like actual long running stuff. So I'm using Lambda in, for instance, the part of the front end that are quote unquote synchronous. So like fetching the feed data and searching for new feeds, those happen in kind of the space of a few seconds. Transcribing, as I say, takes like several minutes, and if your podcast is an hour, it might take like 20 minutes. So I'm using something a little meatier. AWS Batch, I've configured to use AWS Fargate, which is one of their, like, the thing I hate the most about Amazon, by the way, is that there's a million different services, and like, although they're each individually really well documented and have great guides, there's no sort of like entry point for like, if you need this, consider this thing. You just sort of have to look at all of them and be like, oh, you say this word, and you say this word, and you provide this. I see why you're different. Fargate is a lot like EC2 for the purposes of deploying batch jobs. But if you're configured with Fargate, your options are like, how much CPU you want, how much memory you want. All right, go away. If you're configuring EC2, you get to be like, I want GPUs, I want this instance type, blah, 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 blah. I didn't have to care about that because both OpenAI Whisper and John Snow Labs NLP run on sort of, run well on CPU machines. Most AI doesn't. Most AI either benefits strongly or just doesn't work at all if you don't have a GPU machine. So for instance, a lot of stuff, any image processing, I can't run on my laptop. Fortunately, I didn't have to care about that for this. both transcription and text processing are things that run on my local machine, but also run on just like AWS Fargate, where I'm like, give me some CPUs, please. So I deploy a job. If you're bearing along, kickoff thing to API gateway. API gateway goes, this thing's supposed to go to AWS step function. AWS step function is basically a thing that like, it almost basically just redirects to AWS batch. It has an extra thing where it's like, I'm gonna check if there's already a job for this. All right, there's not a job for this. I'm gonna go kick off this other thing. AWS batch spins up, goes, all right, I've got a job definition. You want this many CPUs. You provided me this URL. Hey, Fargate, give me some CPU. And it like spins up some CPU. I claim Amazon's goal is to make CPU like a quantity like sand instead of like a numeric thing, like 1 or 2 CPUs. So Fargate gives me some CPU. And holy crap, I misspelled simpler. And then the front end sits there and basically occasionally checks for the result file. It's expecting an S3. So the transcription job, when it finishes, it has some permissions to go like write out certain files in S3. And the front end will basically like display an icon if there's nothing there. If there is something there, it'll display a happy icon. I don't have like a loop in the front end polling to see if it's done yet because honestly, I can't be bothered. You're waiting like 20 minutes. It's easier to like navigate away from the page and navigate back and just be like, oh, fixed, as a user. Or like as a user who knows that's the functionality than for me as the dev who would have to build the functionality. I learned some stuff about creating Docker containers. If you hear AWS ECS or ECR, it's container stuff. But basically the way AWS batch works is like you configure the kind of resources you want. You make a Docker container with like a script or whatever that's going to do the thing you want, and you upload it, point them at each other, and then every time you click like create job or trigger create job from AWS step function, it basically smacks whatever job definition onto the container you set and just like runs the script and then spins it back down. First time actually properly using Docker for something myself. I've like worked around Docker, but I've never been the person to be like, I'm gonna make a container and oh God, this takes forever to build and stuff. All right, 7 minutes left, hopefully that's good. Takeaways. AWS is cheap. Highly recommend spending some time to just like learn, read the documentation, watch some YouTube videos. It is definitely daunting and overwhelming. Like, I want to say in spite of their best efforts, but I feel like they could make better efforts, but they've really got great docs and guides. It is manageable. If you sort of jump into the part where you're like, oh God, this is overwhelming, and spend like half an hour or an hour just sort of trying to figure it out, you probably will. The biggest point I found stubbing my toe, I sort of alluded to earlier, was anything related to permissions and security, because they don't tell you why they don't have permission, because they can't. So it's stuff like, my transcription job would run for 20 minutes and then be like, yeah, I couldn't write the output file to S3. Be like, all right, well, that's going to be fun to debug. 25 minutes later. Turned out basically I had to like create a new role in AWS IAM and like give it to the batch job and like make sure it had the right permissions to write to S3, and I had been looking at the wrong role, and that's the kind of thing that it like can't give you hints on, which is why like with the OAuth I recommend like figuring out the permissions and security stuff in as like small and isolated of an environment as you can, and then just like having it for reference for always, and being like, I'm just going to copy that and like build on top of it instead of trying to figure it out again. Last main takeaway is, I think for me, as someone who came from like a real back-endy like C++, like Bash, real like I'm on the metal machine background, I think I have an instinctive aversion to things like AWS that sort of look like they're taking choices away from you. They're trying to tell you, like, you don't need to worry about what kind of hardware. And like, as a developer, I'm like, no, I'm worried about what kind of hardware. I really appreciate that AWS is layered. It's like their original products were like database as a service, compute instances as a service, like basically just a thin layer over like, I don't want to have to go buy a physical machine and run my stuff. Can I please rent one? For that reason, all their like later fancier products that are higher level are kind of built on top of lower level stuff. So if you ever find yourself in a place where you're like, oh, API gateway isn't allowing me to throttle in the way I want, like, all right, don't use their throttling. Just like implement it yourself in the Python code. You can always sort of drop down their higher level layer to the thing that's lower down. Like I said, if you don't want to use Fargate because you need GPUs, you can switch it over to EC2. You can always sort of drop down more. My experience with AWS has been that I almost never, very few use cases require you to drop all the way back down to like, I'm going to go to Staples and buy a physical machine and deploy my code. Like AWS has a solution for you somewhere in there that costs pennies. To me, it's been way worth it because I don't like leaving my house. Highly recommend. Read their docs. Take some time to do a test project. Yeah, I think it's really paid off for me, and it's really reshaped how I think about applying a dev team. There's a lot of stuff you see a lot of dev teams do that are sort of reinventing one of these things. You really don't want to burn all your money on that. Yeah.
That's kind of overwhelming, isn't it? You got like 6 or 7 AWS services in there, huh?
Uh-huh.
I was going from a developer too, from a full stack to AWS, and I hated it because it's just like, I hate pressing buttons on the console, so I discovered Terraform, which is kind of like a, I forget what you call it, infrastructure as code language.
Yeah.
So the documentation was much better than AWS.
Nice.
And every time I went to AWS, I felt like they were just marketing other products to me. So,
Okay, good to know.
that journey too was pretty interesting.
Okay, good to know. Yeah, I know they've been adding more infrastructure as code stuff, but they're lagging behind Terraform for sure. I've never actually used Terraform.
Take like reading docs and that kind of stuff to get up to speed, would you say?
Hard to say because you're always sort of bouncing between like how little of this documentation can I read before I might know what's wrong, sort of thing.
I've discovered software engineering, a lot of this stuff is written by people who have English as a second language. They're coders, not documentation people. And the documentation is, why is it never that good? Because it really wasn't intended to. So I always find looking at the source code and then, doing like POCs
Yep.
to be more of it. It took me a long time to kind of figure out that technique, but that was interesting.
That's my approach to almost all APIs. AWS is one where, and I think they've also gotten better at this over time, but like they've really documented everything. The place I get confused the most is, you're right, like the links between services, permissioning, and sometimes they have like very similar names for slightly different things or like very different things. And
Well, I found over the years the documentation is for the CTO and the management. I looked at SAP, Adobe, now AWS, and I found like it looks really good, but even with SAP, a lot of the documentation links are broken.
Uh-huh.
Now, same thing.
Yeah.
You just gotta try it.
Yeah. Yeah, for sure.
Yeah, it's like always the last thing a dev forgets to do is document everything, right? Thanks again, Zeke.
Thank you. I want it. I thought it was mine now.
Thank you. All right. Thanks again for Vegas Theater Company for hosting us. Hiding in the corner there's Ryan. Thanks to him for recording this. And also thanks to all of our presenters today. Before we head out, I do have one JetBrains license to give away, a free year JetBrains license. Anybody interested in that? Not Enterprise, sorry. I got you. Yeah, cool. We usually all go hang out at the Taverna after this, so we'll see you there. Thanks.